Hi. Today we'll be going over a very, very important topic in mathematics, exponents. They're very, very influential in how we write and how we display mathematics, and they show up everywhere from Algebra 1 beyond. So what are exponents? Well, first, I'll start with something more familiar. 2 times 4. Now what does that mean? Well, that basically means, hey, we're adding 2 together 4 times, right? So the end result is we have something like 2 plus 2 plus 2 plus 2, which of course we know is 8, right? That time symbol means, hey, we're adding 2 together 4 times. Exponents are just like this, except instead of adding together something a certain amount of times, we're multiplying it together a certain amount of times, right? Take 2 to the 4. That's the same as 2 times 2 times 2 times 2, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So 2 to the 4 is 16. And that's the core of what exponents are. Given a number that we call the base, we raise it to a certain power, and whatever that power is, we multiply the base that many times, right? So with a base of 2 and a power of 4, that means we're multiplying 2 by itself 4 times, right? 1, 2, 3, 4. If we were multiplying, say, 3 by 6, we'd be multiplying 3 by itself 6 times. Now, of course, we'd solve this, just by doing normal multiplication. What I find helpful in these situations is to, if I don't have a calculator, break it up into chunks I know, right? I know that 3 times 3 is 9. So I have 9 times 9 times 9. I know 9 times 9 is 81, and then I just do some standard multiplication to get 81 times 9, which turns out to be 729. So 3 to the 6 is 729. But exponents aren't just for representing, one single multiplication. We can also do a couple interesting things with exponents. So you notice in this last example, I took 3 to the 6 and I rewrote it as 3 groups of 9s, right? Now the interesting thing about that is that 9 is actually 3 to the 2, which makes sense if we think about it, right? 3 times 3 is indeed 9. But what does that mean? That means we can rewrite 3 to the 6 as 3 to the 2 times 3 to the 2 times 3 to the 2. And we notice something interesting. If we were to take these 2's and add them up, we get 6. It's very interesting. So if we're multiplying together these numbers, the end result is what we would get if we added up their exponents. And that's the first big, real cool thing you can do with exponents besides just representing very, very large numbers. You can split them up into other powers and do operations with them. We can say 3 to the 6 is actually 3 to the 2 times 3 to the 2 times 3 to the 2. Or we could say 3 to the 6 is 3 to the 3 times 3 to the 3. Or 3 to the 4 times 3 to the 2, or so on and so on. As long as these numbers add up to match this exponent here. This is a very interesting relationship, and one that you'll see a lot, and can be really helpful if you want to, say, simplify a very, very large exponent. Another thing to know about exponents is that they grow very, very quickly. These numbers get big fast, and you have to be sure of that, right? Because if we were to, say, plot these values along a number line. Let's say we have something like, 3 times x, right? I want to graph y equals 3x on the number line. It's going to increase pretty rapidly. It's going to go from, 0, and then at 1, right? At 1, I'll do a table. At 0, it's 0. At 1, it's 3. At 2, well, that's 2 times 3, that's 6. So we can see, it's increasing at a pretty high speed. Pretty steep. But what if we have something exponentially? Let's say y equals 3 to the x. What would happen there? Because each time we're not just, multiplying 3 by a certain number. We're raising it to that power. What is that going to look like? Let's go over here. Say x and y. Let's do x and y again. Okay, 0. 3 to the 0. 3 times nothing. What is 3 times nothing? What is 3 to the 0? This is one of the first big interesting things about mathematics. If you raise anything to the 0, anything at all, if you have anything that's to the 0 power, that has an exponent of 0, it will always be 1. It will always be 1. So we have our point as 1. What about 3 to the 1? Well, that's 3 times itself 1 time. That's just 3. So far, not a crazy change. Let's say, x at the 2. 3 to the 2. Oh, 3 times 3 is 9. It's a pretty big increase. What about 3 to the 3? That's 3 times 3 times 3, which is 9 times 3, or 27. That's a pretty big increase. And if we notice, we can keep going on and on and on. These numbers will keep getting bigger and bigger and bigger more rapidly. So if we were to graph this out, right, let's say 0, 1, 1, 3, 2, 9, 3, 27. We actually get something like a curve, right? We keep going up and up and up, faster and faster and faster. And that's another big thing to think about exponents. You're constantly getting bigger and bigger and bigger as fast as possible. You're skyrocketing up, right? So whenever you see an exponent, think, oh, okay, I'm not moving linearly. Because remember, I'm taking these numbers and I'm multiplying them out, all right? So what I should be thinking is, I'm going up super, super, super fast. I'm curving upward into the air, rather than chugging along in a straight line, right? So multiplication is like a train, right, going at a constant speed, or a car driving around a straight path. An exponent is like a rocket ship. It's going faster and faster and faster the higher it goes. It's just zooming up. It's going so fast in comparison. And that's what makes exponents really, really useful, because we can take really, really, really big numbers and write them down into much, much more comfortable forms, right? For example, we can write, 27 as just 3 to the 3, or, 729 as 3 to the 6. It's a convenient shorthand that we can use for a whole bunch of numbers. And as we get bigger, exponents only become more useful, right? We can write 1024 as just 2 to the 10. It's a lot easier than writing 1024 over and over and over again. So that's the basics of exponents, the real basics. When in doubt, just remember, okay, it's like multiplication. Think of it like that. I'm just multiplying a number by itself a certain amount of times, right? So 3 to the 6, and just think, okay, I'm multiplying 3 by 3 by 3 by 3 by 3 by 3. I'm multiplying 3 by itself 6 times. To the 10, I'm multiplying 2 by itself 10 times. What if I need to see it on a graph, right? Well, I know it's multiplication if I have something like this, like 3x. It's just 3 times x. 3 to the x. Oh, I'm raising something to the x. I have x as an exponent, if you will. So I know that my graph is exponential, and I know it's going to be shooting upwards. It's not going to be linear. And that's the basics of exponents. I hope you found it helpful, and I hope you have a great day.